Now, what I want to know is when implementing an edge solution, like an IoT solution, to what extent should workload processes be assigned to the edge as compared to the cloud?
That's a great question, a very important one too. Also very specific to each implementation. I used to joke about the ilities, right? The availability, reliability, all of the kind of the things, scalability, all the things that we want in our applications. We have to look at each, at each use case and decide, is it, if I have to have very low latency, if I have to have nearly 100% uptime, as I said, it's not like the cloud that goes down or the computer on site. It's all those many elements of failure in between that can cause us problems. So mission critical workloads, tend to be as close to the hardware as we can. I mean, if you think about, let's even go really talk about the edge. A PLC, right? 80% of your code in a PLC is typically error handling, safety, all those very, very mission critical things. Highly available hardware, directly connected to the I/O, and then as the mission criticality changes, as you move up the stack, then you can determine, you have a little bit more flexibility. Performance certainly matters quite a bit, right? If I'm increasingly, for example, we're starting to see more and more applications of video analysis and audio analysis and signal analysis being pushed out to the edge, where it used to have, require moving a lot of data to the cloud, crunching some stuff. Now that's becoming very feasible to do at the edge. Human interface, right? Our HMIs and our SCADAs, it doesn't make a lot of sense to me to move a bunch of data to the cloud and then bring the visual experience back. So I think that's another part, is where are the consumers of that data or the users of that data? A number of years ago, my first company was a company called Lighthammer. And basically what that was all about was initially remote visibility to that data, whether remote meant in an office, 100 meters away, or did it mean, someone across the country or across the world. And what we noticed, we started looking at usage patterns of who was consuming the data. Example would be from a historian, right? Lots and lots of data collected very quickly. And we found that the people that are using the most data the most frequently tended to be co-located with that data, right? So that sort of lends itself to an architecture where all that communication happens locally, as opposed to sending masses of amounts of data back and forth to the cloud. I think the analytics world is kind of changing things a little bit. So I talk a lot about kind of the hot path data, right? What's going on right now, and then the kind of cold path or warm path data where you archive it, you do analysis on it. We've seen a lot of people start to move that data into cloud architectures. I think that's a byproduct also of the analytic tools and the AI machine learning tools we have today tend to like to have a big data lake. They're not really well suited to go to the source systems directly. So that's probably influencing adoption of cloud solutions as well.